This video is a sample solution for the ScrabbleScorer task. In this task we have to write a class named ScrabbleScorer, which will count the score of a word using the number of points per tile in the game of Scrabble. There's three methods we need to write on this class. Those will be the scoreForTile method, the scoreForWord method, and then a highest scoring word method. And we also need to write the constructor for this class, which is given here. In this task we should use the skeleton code which is provided here, so I've put that into my class in BlueJ, and we'll be working through this starting with the constructor and then each method in order. To begin with, what I'm going to do is just make this code compile by returning some default values such as 0 from an int returning method or null from a method that should return a string. So this will get rid of the compiler errors at least. I've got one more compiler error, which is that this ScrabbleScorer constructor does not initialize this field named tile scores. If I show that error here, it says variable tile scores might not have been initialized. This variable is final, which means that it must receive a value in the constructor because it can't get a value at any other time. So to solve this problem, we're going to initialize the tile scores field with a map, and this map is going to be a new hash map. And I can use the diamond operator to infer the types of the keys and values in this hash map. So now if I click compile, I'm expecting these syntax errors to go away. It's a good idea to get your code to a point where you'll only have one syntax error at a time so that you know what you're working on next. So that's what I've done to start off with, and now we can write the rest of the ScrabbleScorer constructor. So I need to initialize this array of individual letter scores, so let's do that. I need to create a new array of ints, and I know the contents of this array, so rather than simply saying that this array has 26 elements in it, I'm going to say what those elements are, because I know what the scores of the letters should be. And these scores are given in the table in the task. So I'm going to copy this row and then format this with commas in between the scores. So that's the first row. And then let's copy the next row. And again, I want commas in between these scores. That should be a 10. That should be a 10 as well. So now if I compile this class, I should see no syntax errors. So I've initialized the array of individual letter scores. These are the scores for each letter tile. I've also created the tile scores map, so I'm going to remove this to-do comment as well. And what remains is for me to populate the tile scores map. And this map should map the characters to the integers, which are the characters being the tiles and the integers being the scores of those tiles. So the tiles are in this array of characters, the scores are in this array of ints, and these arrays both have a length of 26, they both have the same length. What we want to do is get pairs of a tile and a score as a char and an int and put those pairs in one at a time. I can't simply write something like this, .put tiles scores. This won't work because the put method takes a character and an integer, but tiles is an array and scores is also an array. So if I compile this, I'll get a type error which says incompatible types char array cannot be converted to a character. To solve this problem, we're going to need to input one tile and one score at a time, and that means I'm going to need a loop that runs 26 times in order to put in each tile and each score individually. So because this loop needs to run 26 times, we're going to need to keep track of which tile and which score we're inputting at the moment. And to do that, I'm going to have a variable to hold the index into both arrays. And that variable is going to be named I. This is a standard way of writing a loop. Start at 0, keep going while I is less than the length of the array, which is tiles.length, or I could write scores.length, that would work as well. and then each time this loop goes around, we're going to increase that index by 1. And now I need to get a tile and a score so that I can put them into this map. Well, the tile is a character, and that's going to come from the tiles array at index I. And the score is an int, and that's going to come from the scores array also at index I. So we're going to get the tile and the score and put those in so that the tile maps to the score in this hash map that we've created. And I want to click compile now to see that I have no syntax errors. Now that I've finished this task, I'm going to remove the to-do comment. So I've populated the tile scores map so that each tile maps to the number of points that that tile is worth. Let's now write the scoreForTile method. And this method should take in a character as its input and return an int as its output, which will be the score for that individual letter tile. The first thing we want to do is make sure that we have an uppercase letter. If this parameter tile has the value of a lowercase letter, then we want to convert it to uppercase. And the way to do this is to use the method character.toUppercase. It's not enough for me to simply write character.toUppercase. This method is going to return a char, so I want to assign that char to the tile variable. This character.toUppercase method is part of the Java standard library. This is a convenience method for using the char primitive type, because char is not an object, char is not a class. A char value, such as tile, doesn't have a method, so I can't write tile.toUppercase. Therefore, we're using the toUppercase static method on the character class. And if you weren't sure what that method was called or how to solve this problem at all, then you can go to Google, search for something like Java character.toUppercase, and you'll find an example where you can see that this method is being used in this kind of way. The next part here is that we want to check if the tile scores map contains this tile. So if it does, so if the tile scores map contains the key, which is the tile I'm looking for, then we want to get the tile score from that map. Otherwise, we want to do something else, and that is actually going to be this return 0 here, because the method comment says that if the character is not a letter, then 0 is returned, and if it's not a letter, then it won't be in the map. It won't be there as a key. I'm using the contains key method here rather than the contains value method, because this map is from characters to integers, so the tiles, which are characters, will be the keys in the map, whereas the scores, which are integers, will be the values in the map. So I want to check that it contains a key because I'm checking that it contains a tile. In this case, we want to return the score of this tile, which is what we get from the map when we call the get method. So I'm going to return tilescores.getTile. And now that I've written this method, I'm going to remove the to-do comments and check that my code compiles. So I see that this compiles with no syntax errors. Let's move on to the next method. In this method, we're calculating the score for a word, given that word as a string, and we must return the score as an int. If we think about how this method needs to work, we're going to need to loop over the characters in the word, and to do that we have this array of characters that's already provided in the skeleton code. So I'm going to need to loop over this char array, and for each tile in the char array, we're going to need to add the score up onto a running total. So that means we're going to need a for each loop, and this is going to be over each tile in the tiles array. This time I don't need to keep track of the index because I'm not using the index, just the tile from the array. That's different to the loop in the constructor where we used the index because I needed to use the same index in two different arrays. Here I'm just iterating over one array, so I don't need the index. I just want the values from that array, so I have one tile at a time. And then what we want to do is keep a running total of the scores of those tiles. So we're going to declare a variable for that running total, which is the score, and the running total will initially be 0. Then this method should return the score at the end of the loop. And each time we see a tile, we want to add its score onto this score variable. To get the score of this tile, we're going to use the scoreForTile method. And now that I've written this loop, I can remove the to-do comment, and let's click compile to make sure I've got no syntax errors here. The last method here should return the highest scoring word from a list of words. So given a list of strings, we're going to find the highest scoring word from that list and return it. However, if the list is empty, then we should return null. The way I'm going to solve this problem is by iterating over this list of words, so I can already write something like for string word from the list of words. I know I'm going to need a loop over this list of words. I know that we're going to need to keep track of the best word from this list. In that case, I'm going to need a variable to keep the best word that I found so far. And initially, I've got a choice here. Either I can set this as null, or I could use words.getZero to get some word from the list. So I could either get the word at index 0, or I could set this to be null to start off with. And then each time we see a word, we want to check whether that's better than what we've got so far. So I'm going to say if it's better, then we're going to update the best word so that best word is word. Now we need a condition to write here. And this condition is going to be if the word I'm looking at, which is word, is better than the best word. And in this sense, better means has a higher score. So we're going to need to call this scoreForWord method. That means I need a variable to know how good this word is and how good the current word is. Therefore, I'm going to declare a variable best score, which initially I'm going to set as 0. And then we're going to say if the score for this word is better than the best score. So if the score for this word is above the best score, then we're going to update the best word, and we should also update the best score. In this case, I've promised myself that we're going to have a variable named score, which will be the score of this word, so let's declare that variable and initialize it. So this variable score will hold the score of the current word that we're looking at, and if that score is better than the best score, then we're going to update the best word. And then at the end of this method, we should return the best word. And now I can remove this to-do comment. Now there is actually a subtle bug left in this method, but I have actually written it in such a way that if the list is empty, then we will return null. Because if the list is empty, then this loop will run 0 times, best word will still be null, and we'll be returning null at the end of the method. So this is almost an entirely correct method, but there's one bug in this method which we'll discover during testing. I'm going to click compile here to make sure there are no syntax errors, and then we'll move on to the second part of this task, which is to write unit tests in a ScrabbleScorer test class. So let's move this over here, and I'm going to create a class named ScrabbleScorer test, and this will be a unit test class. Let's double click on this to open the editor, and I'm going to move this to a new window so that I can have both my implementation and my unit tests visible at once, so I can see the code that I'm testing as I'm writing those tests. I'm not going to need the after and before, I just want the test annotation and the assertion methods. So let's also delete the rest of this code that's generated for me by BlueJ. To start off with, we're going to need to create a ScrabbleScorer object so we can call its methods during the tests. I'm going to declare a private final ScrabbleScorer field, which is named Scorer, and this will be a new ScrabbleScorer. This is the object we'll call our tests on. And there are various requirements that should be tested here. We're not just going to write one test per method, rather we're going to write one test per requirement. The first requirement is that this scoreForTile method should return the score for a particular tile. Let's write a test to make sure it does return the correct score given an uppercase letter. So public void test tile score. In this case, all I'm going to do is call assert equals with the correct score and a few different characters. I'm going to write all of these characters in the same test because they're testing the same behavior, even though I'm going to write a few different assertions. So I'm going to assert that the score for a capital A is 1. And this is what I should get when I call scorer.scoreForTile with the character capital A. And this is in single quotes because it should be a char rather than a string. And then let's write another couple of assertions for some different letters. The score for a B should be, I think, 3. So let's assert that the score for a B is 3. And the score for a Q should be 10. Now that I'm going to compile this and check that the test does actually pass. So I can see that this fails. I've got an index out of bounds exception with index 25. And this means that one of these arrays is not long enough. And I'm sure that this has a length of 26. So this means my score array is missing an element. So let's go back to the requirements, the specification here. It looks like this row here isn't quite long enough. It should have 13 elements. So let's make sure that we've got all of the elements that we should have. Well, this should start 1, 3, 3, 2, but it actually starts 1, 3, 2. So I'm going to fix this here by writing another 3. Let's save this. Recompile and make sure that my test passes, and it does. So let's continue writing these tests. Let's test that I get the correct score for a lowercase tile. This should be lowercase with a capital C. And these assertions will be very similar, but I'm testing a different behavior, which is the lowercase letters. So I want to make sure that I get the correct score for those as well. And let's run these tests. I can see that this passes as well. Let me resize this window so I can read both my class and my tests at the same time. Let's write a test that if it's not a character, if it's not one of those tiles, then we should get a 0. So let's test that behavior. And similarly here, I'm just going to write a few assertions with different tiles that are not letters, and in this case all of the scores should be 0. So let's test that an underscore, a space, and let's say the number 5 should all give me a score of 0 because those aren't real tiles. I'm going to compile this method, test it again, and I can see that this passes. Let's continue writing more tests. I think this is enough tests for the scoreForTile method, so let's move on to the scoreForWord method. In this case, we're going to need to think of what the correct score for a word is before we write the test. I don't want to run my method to get that score because I can't assume that the method I'm testing is written correctly. So we're going to choose some simple words where we know what the correct score should be. Let's test a word where the tiles are all worth 1. In that case, if I have 3 letters, then the score will be 3. And if I use tiles of all value 1, then we'll be able to construct a word. So I could use A, E, and T. So the word ate or eat, for example. So let's use the word eat. And let's also choose another word where the scores are not all 1. So I don't know what the score for this will be yet. Let's write the word panther. And these should be uppercase, I guess, because we're testing that's in the original case, but it doesn't really matter because we've tested the scoreForTile in both the uppercase and the lowercase. So let's work out what the score for panther should be. P is 3, A is 1 more, so that's 4, N is 1 more, so that's 5, T is one more, so that's 6, H is 4, so that's 10, then E and R are both 1, so I should get a score of 12 for the word panther. And let's run these tests. So these tests are passing as well. So the class seems to be written correctly. Let's move on to the highest scoring word method. There's a few different cases to test for this one. The first case I'm going to test is that I get a null if the list is empty. That's the easiest test to write. I'm just going to use the assert null method and say that if I give it an empty list, this is the highest scoring word method. If I give it an empty list, then we should get a null result. And let's call this list words. In this case, I need to declare the variable word, which is a list of strings. And we could create a new array list here for this to be empty. And this means I'm going to need to import array list and list from the java.util package. So let's do that. If I click compile here and run the test, I'm expecting to see that this passes. Here's the empty word list test, which passes. And that means that my highest scoring method does return a null if the list is empty. Let's test the next case, which is the usual case, where I give it a list of words. Let's create a new list again. And let's put some words into this list this time. So we know that eat is a low scoring word. We know that panther should score higher than that. And let's have another lower scoring word so that the best one is in the middle. In that case, we should be testing both the case where the word we're looking at is better than what we had already, and the case where the word we're looking at is not better, because then the last word won't be better. So let's add another low scoring word here. Let's say something like at. That should be a very low scoring word, just 2 points, because each of these tiles is only worth 1. And then let's assert that when we get the highest scoring word from this list, it should be panther. So this will be scorer.highest scoring word of the list of words. I'm going to compile this and run the test. And I can see that this passes. That means that this method, highest scoring word, is actually finding panther from the list correctly. And there's one more case I want to test here, which is that if there is a word that scores 0, then if that's still the highest scoring word from the list, then I want to get that word that scores 0. And there are words that can score 0 if we only use blank tiles. So this is kind of a tricky case to test in. In this case, I want a list of words with just a single element which only uses blanks. And then we're going to assert that when I get the highest scoring word from this list of words, I should get that word with 4 blanks. Let's compile this and run the test. And in this case, the test fails. This has discovered a bug where if the word has a score of 0, then I'm actually getting a null from this method, even though it should return that word that scores 0. So let's understand why this code is returning null when there is a word that scores 0. Well, we're initializing best score to be 0, and we're only updating best word if the score for that word is better than the best score. So the score for this word must be better than 0 for us to update best word. That's an incorrect behavior, because when best word is null, we want to update best word automatically. So there's 2 solutions to this. I could either say if this score is better than what we have so far, or the best word is null. In that case, I don't have anything so far, so I want to update best word anyway. Alternatively, I could set this as something like -1 instead of 0, so that a score of 0 is better than -1. Either of those would be enough to solve this problem. I don't need to write both of these, so I'm going to leave it as 0 and best word equals null here, because I think that's clearer as to my intentions for what this method should do. So let's compile this and compile the tests again and run the tests to make sure that we fixed that bug. And now we can see that all of these tests pass. So since all of our tests are simple enough that we can be confident that the tests are written correctly, therefore we believe the passing tests mean that our code is written correctly as well. That's a complete solution to the ScrabbleScorer and ScrabbleScorer test task. We've written both the ScrabbleScorer class and unit tests for it. In the next video, we'll take a look at a solution for the Scrabble board printer task.